For our first polymorphism example, we're going to see a program that calculates the payroll for a company. So we're going to have a class hierarchy that looks like this, where we have a staff member, and that's our base class. And then we have two types of staff members. We have volunteers. Volunteers won't get paid. And then we have employees who do get paid, and they'll have a salary. And we have two types of employees. First, we have executives. Executives will have a bonus that they get awarded, and then we'll have hourly employees. Now, the difference between an employee and an hourly employee, first I'll keep in mind an hourly employee is an employee, but the employee will have a pay rate that's based off of a salary, whereas the hourly one will have to calculate their salary each time based off of the number of hours they worked. So if we look at our code, here's our staff member class. And we have three data members, the name, the address, and the phone number for the staff member. Those will be used by anything in the hierarchy. They'll all have a name, an address, and a phone. And notice they're protected so that any class that inherits from staff member will get these fields and they'll be able to access them as though they were public. But anything that's using staff member, those will be private and they'll have to use getters and setters. So our constructor sets up those values, the name, address, and phone number. And the toString will generate a string that has the name, address, and phone number of the staff member. And then we have an abstract method pay. So we don't know how to calculate the pay for the staff members. We just know that every derived class of staff member needs to implement a pay class if we're going to actually use that, if it's going to be a concrete class that's non-abstract. So our volunteer doesn't need to do much. Its constructor will simply call the superclass constructor. So again, this is the staff member constructor with the name, address, and phone. And then their pay is very easy to calculate. We just return 0.0. So the employee class is a little more involved. It's still going to have a name, an address, and a phone number. And we can use the superclass constructor to set those values up. But notice we're also including a social security number and a pay rate. So now our toString, first of all, we're going to call the superclass toString to set up the name, address, and phone number in the string, and we'll add the social security number to that string, but we're not going to add the pay rate. We'll keep that a secret. Or to pay them, we're just going to return whatever their pay rate is, so that'll be their biweekly salary. So the executive class is going to extend employee. So it's going to be an employee, but it's also going to be a staff member. So we're going to get everything from staff member, everything from employee, and we're going to call the employee constructor to deal with the name, address, phone, social security number, and pay rate. And then we add a new member called bonus, which we initialize to 0. And then we set up a new method called award bonus. So if that executive earns a bonus throughout the year, we'll set this value. Otherwise, it'll be 0 when it comes time to pay them. And for the pay rate, we get whatever their pay rate is, and we add a bonus. Now, once we've done this, they've been paid their bonus, so we reset the bonus back to 0, and then return whatever the pay rate or their payment is supposed to be for this period. And so our last staff member class is going to be hourly. It will also extend employee, and so since employee is a staff member, it also is extending staff member, but we're adding a new class member here called hours worked. Again, just like with the executive, we call the superclasses constructor to set up the name, address, phone, social security, and pay rate. In the constructor, we set the hours worked to 0. So this class is going to need some way for us to set this hours worked. So we're going to create a setter called add hours. And that can be called whenever that employee works. Now notice, this is always going to add whatever those hours are to the number they've already worked. So that way we can call this multiple times. Okay, on this day you worked this many hours and so forth. And then to calculate their pay, we're going to multiply their pay rate. Notice now it's not a salary, it's an hourly rate times the number of hours worked. And then we're going to reset the hours worked to 0 so that we can use this the next pay period, and we'll return what their payment should be. and then we're going to override the toString method. So we'll take the employee toString method and add the current hours to that string. Now with the executive, we didn't modify the employee toString method, or we didn't override it, because we were happy to just use what was already there. The only thing that executive adds is bonus, and that bonus, just like the pay rate, would be secret, and so we wouldn't put that when we print out their pay. These are the 5 classes that set up this class hierarchy. And so now let's see how we use that. We're going to create this staff class. Now, ideally, you would have your staff so that you would set up an empty staff and then you would add members to it. As a shortcut here, just because we haven't quite learned everything we need, notice in this case, the staff constructor is going to set up some employees, and then it's going to award bonus to one of the executives and add some hours to the hourly employee. Now, one thing to keep in mind here is, again, this is in the constructor. This is probably things that we should provide service methods to, so that whoever is setting up a staff can add employees and also award the bonuses and so forth. But this is just to demonstrate how polymorphism works. And so how this data gets here, we could just assume, hey, look, that's the data. We have these employees, and we have the executive gets a bonus, and the hourly worker works 40 hours. Now, one thing you may notice, though, is that this is all in a single array. Even though we have an executive, an employee, an hourly employee, a volunteer, these are all in a staff member array, because each of these is a staff member. Even hourly, which extends employee, not staff member, is still a staff member, since employee extends staff member. So this is a polymorphic reference. Each of these array indices has a polymorphic reference to some staff member class or staff member object at this point. And now, when we actually have payday, we just need to go through this list and we call the pay method. Now notice, this is a polymorphic call. What pay method is going to get called? We've defined several. We have one for volunteer, one for employee, one for executive, and one for hourly. Well, depending on the type that staff list in this index is, that's the one that'll get called. So for the executive, which is index 0, it's going to call this method. Whereas when we get to the employees, it'll call this method. And likewise with hourly employees, it'll call this method. And so that way we don't have to put something in here to say, hey, if the employee type is executive, then calculate it this way. Else, if it's a volunteer, do this. We can just say pay and trust that the object itself will handle its own pay method correctly. It'll call the correct thing. It'll do everything that it needs. So it really saves a lot of typing here. And it also avoids us having to write a really long, complicated if, then, else structure. So now our final driver class, all we do is we set up a new staff. And again, if we made this more general purpose, once we've set up the new staff, then we would want to add employees or staff members. We would want to set up bonuses and hours worked and so forth. And then finally, once we're ready to actually pay everybody, we call this payday method. So let's run this, and you can see it prints everybody correctly. And notice the executive, we have name, address, phone, social security number. For the hourly, we have the number of hours they worked. And then for the volunteers, we just have their name, address, and phone number. Okay, so that's a quick example of polymorphism. And in the next example, we'll tie together interfaces and polymorphism using the animal class hierarchy that we created in the last module.